Let's take a look at one last example of algebra, and then we're going to move on to some calculus operations. We want to write some MATLAB code to create a menu of algebraic options or operations. And so user is going to enter an algebraic statement in terms of x, and then the user is going to enter E for expanding, F for factoring, P for partial fractions, S for simplifying. And then if the user enters something else other than EFPS, we're going to print an error message. And of course, we're going to print the response to the screen. All right, so first things first, we have to define a symbolic variable, and we have to get the function from the user. So I'm just going to call it fun, and function is going to be equal to input. And I'm going to say enter a function in terms of x. And then what I'm going to do is I'm going to get the choice from the user, which I'll call choice. And choice is going to be input. And I'm going to say enter E for expand. We'll say, what was it, F for factor. And we had P for decomposition. And we had S for simplify. All right, so now we have the choices from the user. And at this point, now we can just go through and do an if statement. So we're going to say, if for some reason choice equals E, and remember you have to put the character in quotes, we're just going to say that we're going to expand the function. So let's just redefine the function. Let's say fun is going to be equal to expand fun. Right? And remember, with the expand function, you don't necessarily have to do a for loop to print it out. Okay, so this one's pretty easy. So we're going to say fprintf. And we're going to say the expanded function is, and we're going to use %s, all right, because we like the string for this one. And then we're going to backslash it, and we're just going to say fun. All right, now let's just go ahead and run this to see if we're good. All right, so I'm going to run it, and I'm going to do a really basic example. We'll just do something like 2x times, or we could say plus 5x. Oh, that's expanded. So we're going to say 2x times, let's say quantity x minus 4. All right, so that should be pretty easy. And we are going to expand. And remember, when you're typing this in, make sure to put it in quotes, the single accents, and it gives us the expanded function. All right, so we're on the right track with everything. All right, now we can just do else if. And we can just go ahead and basically copy this code, and we just change a few lines. All right, so I'm just going to put that here. And then I'm going to copy this 3 more times, or 2 more times, excuse me. And I'll format it. And now we could just do each of the different operations. So we don't have to sit there and type it out forever. Right? So if we want to factor this, so choice equals factor, function is going to be equal to factor. And I remember up here I spelled terms wrong. Not that it matters, but I guess it does. Now remember, this one's a sneaky one because with factor, it only gives you in the list form. All right, so we have to figure out how many we're going to print out, how many factors. So let's just make a for loop. So let's say for I equals 1 colon size of fun, and I think it was comma 1. So let's just try 1 this time. And if it doesn't work, I'll run it. And if it doesn't work, no big deal. And I'm going to take this and I'm going to move it up here. And we're going to say the factored function is is, and we're going to get rid of this because we don't want anything yet. All right, so we're going to print, and we're going to say for I equals 1, we're going to do print f. And we're just going to do, like we did before, we can just do parenthesis %s, and then we can just say fun on. And we can end our for loop, and then we can do an print f at the end of the \n. All right, so let me go ahead and test this out because I can't remember if it's 1 or 2. You know, I know I just did it. So let's just go ahead and run it, and something doesn't like, oh, right here. And I'm probably going to have to change these really quickly as well because there's so many different choices. So let's call that P, and let's call this one S. Okay, so we have them all in there now. All right, so let's go ahead and run this just to make sure the factor's okay. So let's say x squared minus 2x plus 1, and we're going to factor this time. All right, so it might be 2. Let's try 2 because it only got the first one there. So let's do x to the 10th minus 1, or x to the 16th minus 1, and we'll factor it. There we go. Okay, so that factored out nicely this time. All right, so I have to remember that for myself too, that it's 2 and not 1. All right, partial fraction is easy. So we're going to say if choice is equal to P, then we are going to fun is equal to part frac fun comma x, and the decomposition is %s, okay? And then finally, we're going to simplify. And the simplified function. All right, so let me try both of these just to make sure we're good, and then we can do the error handling because we're not done with that yet. So let's run this. And we want to do a partial fraction, so we did that one earlier. So let's say we have x cubed minus 2x squared plus x, and we are going to do the partial fraction decomposition. All right, and there it goes. It gives us the decomposition right here, really nicely. Right? And then finally, let's do simplify. So we'll do something really nice and easy to 2x plus 5x. All right, and we're going to simplify that, and that gives us 7x. Okay, so it looks like all of our algebraic functions are now good at this point. Right? Now, the last thing we need to do is we need to do some error checking. Okay, so we're going to say else, and we could just do that error. So remember this from the last section, error, and we can just say not a valid choice. All right. So let's just run it one last time, and let's just see what happens if I put something in there that doesn't make any sense. All right, so let's just do O. All right, and notice right here, we have our error checking. It says not a valid choice. Okay, so pretty cool. So now we have a menu that can do a whole bunch of algebraic operations for us. All right, and of course, in real life, where would we use this? Well, if we're programming something like Symbolic or another online sort of checker like Wolfram Alpha, then this is sort of like some of the underlying context as to what's going on there. Now, of course, those are much more robust, and there's deeper level going on of programming, but this is sort of like the surface layer as to the choices, et cetera, as to what's going on. With those sorts of things, they're smart enough to be able to recognize keystroke errors. So there's a number of different permutations that a user could input and still get the right solution or the intended solution out of it. But for us, this is a pretty decent little start to being able to do some of those sorts of things. All right, so our next video, we're going to start taking a look at some calculus operations, limits, derivatives, integrals, that sort of good stuff.